Hi, everybody. Happy Monday. For those of you who were on the online class yesterday, as you know, I had all kinds of technical problems, so I'm re-recording this video after the fact to go over the content of what we dealt with on Monday's class. Okay, everybody. Okay, so I want to just go, a lot of what we dealt with Monday was looking over how to complete this course. This is something I'm going over with all my classes this week, and kind of as there's only a couple weeks left, and you should email from me about this. But all the same information is also available on my website. So, oops, just going to go to the first page of my website. And right here, as it says right here, we are now going into the last few weeks of this semester and this school year. And the school has marked June the 15th as the last day to complete essentially course materials, to get any new materials. I'm going to be done way before that. Here are the 4 basic facts you need to know about ending this unusual year, a year of a global pandemic and a school closure. First important fact, your final mark in my course will be the exact same mark that was on the March 13th, essentially the day the school closed. It was the same mark as the last reporting period. It is what's called the baseline mark. The province has instructed us as teachers that this is what your mark will be. There is a slight possibility that it could go up from there, but it'll never go down from there. Okay? We'll talk more about that in a minute. Okay? So that's the first basic fact. Second basic fact, there will be no required final assessment in any course. Okay? That means no final exam, not that there ever was one in computer science, and no required final project. A final project is not required for the computer science course. Okay? However, there is an option for a final assessment that I'm going to talk about in a minute. Not required, but an option. Okay, the next important fact, your comment on a report card is something that can change. Okay, so unlike your mark, which is locked, the comment I'm going to put on your report card is one of 4 possible comments, which I'm going to go over in a second. And finally, if you have made no attempts at online learning since the school is closed, as you will see, you will be put into the final report card comment category. And what has been said to us as teachers is that there is a possibility that any student that has made no attempts at connecting online might have to do a credit recovery on that course next year. Now, as it says in the email, there are lots of exceptions to this rule, okay? It's not one size fits all, that it's always going to be the same. There are lots of exceptions. It depends on the student. It depends on the course. It depends on what grade. There's lots of things there. So it's possible, for example, if you're doing Math 20S pre-calculus and you did no engagement, that the school will require you to do a credit recovery of math pre-calculus before you take grade 11 pre-calculus. But as far as option courses go, I don't know what the answers will be. I know that is a possibility. So if you're the student who's made no attempts at connecting online, then stay tuned. I have a possible solution to that. Okay, also in the email I gave you was the official provincial documentation for that. So there's links, for example, to what the province of Manitoba said specifically about learning at home and continuous learning. I've in the past connected to this document that kind of explained what the province was talking about with this. And even this new one, right on the province's website about what learning recovery, what online learning means for students this year. And you can see here, I've even included a quote from there that backs up what I just said, that your mark is essentially locked in with a possibility, or what they use the word opportunity, to make their mark improve. Okay? Then in that same document, it outlines what the 4 report card comments that I will be using for your final report card will be, it will be one of these 4 comments right here. Okay? So now you know what your mark is going to be on your final report card, and now you see what one of 4 possible report card comments, will be. Let's start with the first one. Consistently. The way the province has defined this is that you participated all the time, or almost all the time, in online learning, which means you, for me and for my class, you connected to online classes like this one, or you did some work and then handed it in. Or if you were a student who couldn't connect due to technical problems, couldn't get the right software, or you had no internet at home, then you contacted me and I prepared a printed booklet for you that you took home and then got back to me in some format. If you did this all of the time or most of the time over the last 2 months, then you would be in the category of a consistently. And that's what will appear on your report card. The next step down from that would be usually. This would mean the same thing, that you in some way are engaging in online learning, but the province has defined that as you've done that about half of the time. So essentially, out of all the things you could have done to connect with me online, you did about half of them. The next step down from that would be sometimes. With that, they define that as less than half. So maybe you did answer 1 or 2 emails at the beginning of the school closure. Maybe you did a survey. Maybe you handed in 1 or 2 things. This would be maybe a category somehow between sometimes and usually. So these would be one of the 2 possible report card comments I could make. And in these last 2 weeks, obviously what you do in these next 2 weeks can obviously affect these spots. And then finally, the last category that you can get put into is the rarely category, which means you never or almost never did remote learning. You essentially ghosted me since the school closed in mid-March. Okay? We just talked about that. If you are in that category, the school has asked me to submit your name for possible credit recovery. Okay? But those will be the 4 possible comments that'll go on your report card. I then added a section in the email about my personal thoughts on the matter, right? So obviously, I've already posted over the school closure different reasons why I think it would be a good idea for you to continue your learning, okay? Not just from the fact that I'm a teacher and I think learning is important, but not just because I wanted you to make sure you didn't have to do credit recovery. Your mark was essentially locked in, but I wanted to make sure I fit the mandates as well, okay? I wanted to always let you know that I was flexible, okay? I wanted you to know that there were lots of ways you could connect with me. There's a big list of them in the email here of all the different ways you could have connected with me. I wanted to let you know that I understood that you had a lot going on. You had more than my course, so you had to balance your time. Maybe you had to balance it not just with all the courses, but with other relatives you had in the house that you had to share computers with. The province mandated that we only do a maximum of 3 hours a week expectation. I feel like I was well underneath that because I had to balance that. So I really kind of feel like I've done my part to try to get you guys to engage. As I said, there's a list of different things I've done for you guys here. This was in the email as well, including some ways to even inspire you to kind of continue learning, okay? Added a new resources page to my website, etc. So that's my pitch as to not just for the report card comment and the mark, but why I wanted you to engage online. And this is especially important for any of you students in grade 11, 10, or 9 who are planning on taking more computer science with me. The last thing you want is to feel really unprepared for the next course you're taking. But, and I think this is true across the board for every teacher. I also want you guys to know that no matter what level of engagement you have, every teacher in the school is right now preparing that when we start next fall, hopefully, or whenever we start in a more normal type of school environment, we expect that we're going to have to spend a little extra time getting most students caught up to sort of the level you should be at the start of that course. So for example, if I was your grade 11 math teacher, I should probably expect that when I start grade 11 math, I would expect to have to kind of go over a little more details from grade 10 math than I normally would. And it would be the same in my computer science classes. When I start grade 12 computer science class, I'm going to probably spend a little extra time reviewing grade 11 computer science, knowing the unusual circumstances that we're all in. But that's also a good reason why you want to stay on track with your learning, so you don't feel like really behind starting a new course. Okay. Now, as we enter the last few weeks of this course, I also included in the email ways that those 4 categories would be kind of fitting to what you want to do. So if you feel you're consistently been connecting to computer science since school closed, you've been tuning into the online classes like this one, if you've been handing in some work, I don't want to say all your work, but you've been handing in work almost every week, okay, either through online or printed, well, then I would say that you are essentially done your computer science course. It's done, okay? If you wish to do some sort of a final assessment, that is an option for you, not a requirement. That final assessment as well does not have to be a traditional final project, programmed and put together. It's not going to be necessarily that. It can be that if you want to do that. That could be maybe something fun you'd want to do. But it could also be something in a more non-traditional way. So I'm going to go over that in a little bit more detail later. What would be the benefit of doing this final project or final assessment if you have been consistently tuning in or consistently doing your work? Well, now I feel like now I could possibly raise that final mark a little bit more because you've demonstrated learning beyond what kind of you needed to. Okay, what if it is usually? What if you're in that category? You've done some of that stuff. Well, then what I say is you could do some sort of final assessment. Okay, again, not required. Why would you want to do that? Well, if you do some sort of final assessment, then I feel like that is where I could move you up from usually on your report card comment to consistently. Remember, your mark isn't changing, okay? So could I move you up from usually to consistently? So if you've done about half online engagement and now you're like, oh, I'd like to have Mr. Watts put consistently on my report card as a comment, this would be where something like a little bit of a final assessment would be the thing I could use to essentially make up for the fact that you haven't engaged, more than half the time. Okay, then now what I want to talk about are the last 2 categories. This is where I'd say it's even more important to consider this option. If you are in the sometimes or the rarely category, especially if you are in the rarely category, you haven't done anything really since school closure, and you're worried I'm going to put rarely on your report card mark, you're worried that maybe you're going to be moved to the option of, credit recovery. Well, now I would say it's more of a must, okay? I mean, yes, you could go back and do the work that, over the last 2 months you haven't been doing, but why not instead think about doing a final project, which I will essentially count in lieu, meaning as a substitute for the last few months of not engaging. So it's an offer, okay? Your mark isn't going to change, but I will move you up from the rarely category to sometimes or even categories above. And the final assessment gives you an option to do that, okay? Same with sometimes, it's the same idea there, move you up. Okay, so let's talk about that final assessment, okay? If you want, you could do a final project in a traditional way. You could code something, showing me what you've learned in the course, like a game. Keep in mind, I will not be marking it the way I would normally mark it because it's not something that's required of everybody. But that's not what you have to do, okay? All I really am looking for a final assessment is a way to summarize what you've learned in a course, okay? So if you read the link here to what would have been the offline assessment for those students who couldn't actually work on computer science on a computer, had to actually work on a printed piece of material, I actually created a last page to summarize the learning in that course. Okay, so it's actually summarized there, what you could do. And I even included a snippet of it on my website here and in that email, which is basically, one way is to write basically an essay saying, here's what computer science this course is about. But it doesn't have to be an essay. It could be something more like a PowerPoint or a recorded video or something like that. I'm giving you a lot of freedom there to essentially summarize all the stuff you've learned in that course. Okay? So I have the grade 10 example. I have a grade 12 example. And if you're not sure, you can always contact me. Okay? As it says in there, if this is something you are considering, something a little bit different, let me know what you're doing and if you have any sort of outside the box ideas on how to accomplish that. And that's it. That's finishing this course. There's a lot of different options there for doing that. Okay? So that's all available for you guys as a way to finish up this course. Whew. Okay. The other thing we did, just going to pause for a second. Okay, because I actually want to use that part of the video for other classes to go over the same thing. Now what I want to just say is I did have one more option that you could have tuned in yesterday to not easily see. But if I go back to our last week, back on May 5th, May 25th, last Monday, I recorded a video of some extras content, okay? You may remember it was a media player that played media and sounds and stuff in visual. That media player example is an example of some kind of a final assessment sort of a thing, okay? It was me going through this. I do this normally in class, go over a few extras at the end of the course. None of them are worth marks, but they essentially allow you to take a look at some of that. And what I did yesterday is I also wanted to go over one more extras example, which I'm going to go over with you now. I'm going to show you what the finished product looks like. The finished product for this little extras example is what I would call a mini Pac-Man game. Extremely mini, because rather than use pictures for a Pac-Man game, it just uses rectangles, colored rectangles. The yellow colored rectangle represents Pac-Man. The blue colored rectangle represents a wall. The green colored rectangle, a ghost. And the white colored rectangle, a dot. Okay? Obviously, in a real Pac-Man game, we would have multiple walls, multiple dots, and even 4 different ghosts. Still have just the one Pac-Man. So in the mini version, you can use the keyboard to control the Pac-Man character, make it move around. If the Pac-Man character touches the dot will disappear, like it would in a Pac-Man game. If the Pac-Man character touches the wall, it's stopped. It can't go through the wall. From either of 4 different directions, it cannot penetrate through the wall. So what we're talking about is collision detection and collision reaction. And if it touches the ghost, it's just game over. It just shuts down. So it's a much smaller version of Pac-Man. It's not really a game, but what it does is it gives you sort of some breadcrumbs as things you could do to follow this. So what I did was I walked through the process of doing this, and that's what I'm going to do for you guys right now. So what the design is it's very simply just a series of picture boxes. Pac-Man, the wall, the ghost, and the dot were all 4 of those things were just picture boxes. Once the picture box was drawn on, like it is here, Okay? All I did was change the background color property, right? So, you know, Pac-Man was yellow, the wall was blue, et cetera, et cetera, et cetera. And then I named the 4 objects, right? So dot 1, ghost 1, and wall 1. Those were named because I put a 1 on there because it implies that you could make more of them if you were taking this mini example and expanding it out into a real example. Pac-Man, well, that was just simply me presenting, sorry, that's just Pac-Man itself, so I didn't have to put a 1 on that. I still had my form, which I didn't bother naming, and I also added what's called a timer. Okay, timers was something covered in the last exercise example. With the timer, the only property I set for the timer was that it was enabled, and I reduced the interval down to just 1 millisecond. So every 1/1000th of a second, the timer would run. With the form, I changed a couple things. I set the border style to none, so it has no border on it. I obviously set the background color to black, and there we go. So when you hit start, it starts full. Oh, and the other one was the window state was set to maximized. So when you play this, it maximizes form 1, takes away any border, and makes it black. Okay. I double-click the timer to put code in it. I'll show you the code in a second. But one other thing in this extras is in the properties window, I now introduce this little lightning bolt feature right here in the properties window. You can click on that lightning bolt and the properties change. If you click on the one beside it, it goes back to the regular properties. But what the lightning bolt does is it's not properties of the form, it's essentially actions that this form can do. All the actions, can't write well, but that a form can do. So it's more like sort of action events. So what I did is I found the one called key down, which means when the user presses a key, and what you do is you double click key down to get to the code. Okay, so from this point on, we're going to look at the code for this example. Starting with some global variables that we created. So under the words public partial class, we made some global variables, starting with 4 constants. 4 things that aren't going to change. And what these things are is they are special key codes that that are needed when the user presses a key on the keyboard. So for me to end this program, which I just made the escape key, it's going to be a key code for 27. Now you don't need to know these codes, they are just ones that would eventually come up. You can do a quick internet search to find them, but I just wanted to provide them for you. So the key number for escape is the number 27. Up, down, left, and right, I use the 4 arrows on the keyboard. But I know a lot of you in your gaming like to use keys other than up, down, left, right. You like to sometimes use WSAD. So I also here in a comment included what those key codes are if you'd rather use those instead to move around the form. So 87 for W, et cetera, et cetera, et cetera. All right. Then I made a couple other constants. Since this thing will be moving around on the screen, a few extra spaces in there, I just basically made 1 through 4 the different directions. And then I made 0 when a character is stopped. When it's stopped, it goes to 0. So if it's moving up, it's going to be the number 1. Down is 2, left and right. And that way, when I actually go to code it, I don't have to put in numbers. I can put in words instead. These words, these constants. All right. Then we started making some variables. The first one is a way to determine which direction Pac-Man is going. So actually, instead of 0, I'm going to put that Pac-Man is stopped right here, because I think that makes more sense. It now remembers that Pac-Man is currently stopped. Obviously, when a key is pressed, that's going to change. But this is what it does. It remembers Pac-Man's direction. Okay. Now, what I did next is I'm going to make a series of variables for each of the 4 objects. So starting with Pac-Man, I'm going to call them coordinates. They're going to track where Pac-Man is. So let's say this was Pac-Man, okay? One thing I'm going to track is where the top of that picture box is, okay? It's going to be some number. That's what this variable is for. I also need to keep track of where the left of Pac-Man is. So if this is the top, this would be the left. Okay? So it's essentially tracking that sort of edge and that edge for Pac-Man. Now eventually I'm going to also want to know where the bottom of Pac-Man is, because if I'm doing collision detection, it's not always going to collide from the top. Similarly, I'm also going to need to know where the right side of that picture box is. And in order to help with that, I've created 2 more variables down here, which one represents essentially the width of this box, how wide it is, and one represents the height, or how high this is, of that box. If I have all of these numbers, all 6 of these numbers right here, I essentially have what you could call a bounding box, or for those of you in the gaming community, a hit box around the object that I'm detecting. Okay? And since I had them for Pac-Man, I'm also going to have them for the ghost. Top, bottom, left, right, width, and height. I'm putting a little 1 on there, implying that maybe if I expanded this out, I could also have multiple for the other 3 ghosts if I wanted to in the future. I also have them for the dot, and I have them for the wall. So I've made 6 variables for each of those 4 things. So a total of 24 variables. Now, let's take a look at the code for what happens when the user presses a key down. Okay? As I said, this is that little lightning bolt thing. Well, the first thing I do is I use this E, which is available to you right here, to get a value for the integer that is the code for which key the user pressed. And then, based on that, I can use an if statement. If that code was, for example, the end code, which was the number I put up at the top there, then I just shut down the program. I say application.exit. So that means if they hit the escape key, which is key 27, it reads that key value in, the if statement detected that key value, and it shuts the program down. Then what the rest of the if statement says is, well, okay, but what if it's up, down, left, or right? Well, then based on that, I change that variable that keeps track of Pac-Man's direction to be either up, down, left, or right. So notice key up matches with move up. Key right matches with move right. And if it's some other key, something other than those 4 keys, then I just stop Pac-Man, which I didn't show that in the demo, but I'm going to do it now. I'm just going to move Pac-Man. If I press some other key, it stops. Okay. That doesn't actually move Pac-Man. What does the movement is the timer code. The rest of the code for the example all works inside of the timer. Every 1 millisecond, it starts running the timer code. So the timer is constantly running. So what does the timer need to do? Well, it needs to do 4 big things. It needs to figure out where everything is, get all the coordinates for Pac-Man, wall, dot, and ghost. Move the coordinates for Pac-Man. Pac-Man's the only object moving. So based on a direction, it shifts those coordinates a little bit, checks for any collisions, and then actually redraws everything on the screen. And the only thing it really needs to redraw is Pac-Man. So let's start with the first part of this, retrieving the coordinates. So to do this, I need to get those 6 numbers. 4 of them I get from the picture box itself. So the left of Pac-Man, I go to the picture box, dot left, dot top, dot width, and dot height. So the first four coordinates I pull right out of the picture box, but bottom and right are calculated by just doing a quick addition, top plus height, left plus width. And that gives me all 6 numbers. So now I have all of the numbers to create a hitbox. I do the same thing with the ghost and the dot. So it's the exact same code, just instead of ghost or instead of Pac-Man, it's the pick of the wall or the pick of the dot. So it's the exact same code. So this grabs all those coordinates. Now I'm going to move Pac-Man's coordinates. So the first thing I did is I made a little constant that says, you know what, I'm going to move Pac-Man 5 pixels. You can change this number, obviously. This is a number that you can modify to move it faster or slower, just like you can modify the timer, the interval of the timer to move it faster and slower. The timer changes speed, and this constant right here changes the distance it moves. And if you think about, that's what movement is. It's distance moved over time. That's what we call speed. So speed is the modification of those one or both of those 2 numbers. Okay. Then the next thing the code did is it used a if statement that says, okay, based on this direction, the Pac-Man direction, if that direction was up, I am going to adjust some of those coordinates. So for example, if it's up, I'm going to take Pac-Man's top and say subtract a certain amount. If I'm moving down, I'm going to add a certain amount. If I'm moving left or right, it's not the top I adjust, but it's the left I adjust by either adding or subtracting. So I'm going to just pause here on this video for a second just to let that code sort of stand there for a second. And that is the if statement that actually adjusts the movement of Pac-Man. Then down here is those same 2 lines to get the bottom and the right all over again. Because now that I've adjusted the top or the left, I have to recalculate the bottom and the right of the hitbox so that they're correct now. So these, and I know I've made if statements without curly brackets, but those 1, 2, 3, 4, 5, 6 lines of code right here are essentially what moves the coordinates for Pac-Man. Now what I'm going to do is jump to the bottom of this code. So I'm going to skip past a bunch of collision detection code for a second. And then just say, okay, once I've moved the coordinates, then I put them back into the picture box. So now I put the picture box on this side and the coordinate on this side to move them back. So the left goes back to the picture box and the top goes back to the picture box, which actually redraws Pac-Man or essentially moves Pac-Man back into its new spot. Okay? So that's why when you saw my demo, when I hit the arrow key, the timer is actually moving it and on those last 2 lines based on the coordinate that was there. Finally, the hardest part of this is the collision detection. Okay? So to do collision detection, let's move that down. Okay? What we're doing with collision detection is we're using a big, powerful if statement to check to see if one set of coordinates is essentially overlapping or hitting another set of coordinates. So for example, are the 6 numbers that are tracking Pac-Man matching up with the 6 numbers for the dot? The easiest way to think of this is one hit box. So if I had a box like this, is touching another hit box somehow. Maybe it's touching down here, maybe it's touching over here, maybe somehow they're overlapping one another. So to do that, I've laid out the if statement for you. It is tricky. It's a tricky if statement. Okay, it's right here for you. So basically, if Pac-Man touches the dot, I make the dot invisible. But then there's another weird thing about this. When you have 2 rectangles that are different sizes, you need to do what's called 2-way collision detection. Is Pac-Man touching the dot? Is the dot touching Pac-Man? So I have to make that if statement even more complex. So this is why when you go to type this in, if you're going to try this, this is kind of like, you notice there's a lot of curly round brackets, there's weird and symbols, there's weird or symbols. It's a lot. So what I might recommend you do when you get to that part of the example, if you're trying it, is to actually try something that I've only briefly been talking about at the end of this kind of course. Something on the 20th page that's always been there is this weird thing on my 20th page called GitHub. If you go to GitHub, which is all the code, and you go to 20S, and you keep going in, Computer Science 20S, and you go down inside of there to Programming Extras 2, which is right here. Not the designer, not this file, but the one that says ends in .cs, this project file. If you click on it, you'll actually get the code for this example, all of it. And right here, you can see there's that if statement. You can find it in there. And this allows you to actually copy and paste it right off of GitHub. So you don't have to type it. I mean, you might have to change it, like add a 1 there or something like that. But at least then it gives you a little of an idea there. Or you could just pause this video right here to do this. We then did the same thing with the ghost. It's the same code, except it says ghost instead of dot. It reacts a little different. So when the dot was collided with, the dot became invisible. When a ghost is collided with, it closes the program. And then to do the wall, that's a little bit different even more. I'm going to do that in 2 parts. I'm going to check for a collision and then react to the collision. So it's sort of 2 parts. First check, then react. So what I did is I made a little Boolean variable that says, am I hitting the wall? And I started off false. Then I have the exact same if statement we saw a few seconds ago. And if I hit the wall, I set that Boolean variable to be true. Otherwise, it stays false. So if I touch a wall, this thing is true. Then the next piece of code, and the final piece of code, reacts to that collision. Okay? So if that Boolean variable was true, it would then move on to the code inside. If it's not, it would skip on right past this. Again, you have to kind of know about if statements for this to work. Because if I'm hitting a wall and the direction I was going was down, then I have to adjust Pac-Man's top number so that it's no longer hitting the wall. That's why I subtract 1 off this. Or if I'm moving up, that's why I add 1. Or left and right. And then once again, I recalculate the last 2. So anyways, that code is right there for you if you want to take a look at it. Let me get the little blue lines off there. Actually, let me try and make it a little bit clearer for you guys. There it is. So that would be what you would do if you hit the wall. You could also, again, go on GitHub. And on GitHub, I made it with the brackets on there. But it's essentially the same code. And that would be it. Then it goes to the redrawing part. And that would be the mini Pac-Man example, all laid out there for you. Okay? And it works the way you've seen it work. Oops. Okay, so that's it, everybody. That's how you end the course. That's that second example. This video will go upline. I'll see you guys next week. Have a good day.